We've spent a lot of time talking about parallelograms, but obviously not every quadrilateral is going to be a parallelogram. Some will not have any special classifications at all, and we'll just continue to call them quadrilaterals. Some will be parallelograms, and that only happens, as we've seen, where both sets of opposite sides are parallel. But not every quadrilateral is like that, and in fact there are other special classifications of quadrilaterals that don't involve both sets of opposite sides being parallel. And so this video, which is very brief, is going to look at the two remaining classifications of quadrilaterals, trapezoids and kites, as well as see some definitions related to them. So we don't need every special type of quadrilateral to be a parallelogram. If one set of sides is parallel, not congruent and parallel, because then it would be a parallelogram, but just parallel generally, that's what we call a trapezoid. And a trapezoid, by definition, is just a type of quadrilateral that has exactly one set of parallel sides. In this case, it is the top and the bottom sides that are parallel, and we call those the bases. And we have two non-parallel sides that connect those bases. So go ahead, pause the video, copy down the definition of trapezoid, come back when you're ready to move on. If we happen to have a trapezoid where the non-parallel sides are congruent, then we have something called an isosceles trapezoid. Notice that because the two sides are parallel, if the bases are congruent, again, the bases being the parallel sides of the trapezoid, if the bases are congruent, then we get into one of the properties that we can use to prove that something is a parallelogram. And a trapezoid, by definition, has one and only one, or exactly one set of parallel opposite sides. So go ahead, pause the video, copy down the diagram and the definition of an isosceles trapezoid, come back when you're ready to move on. So in triangles, we saw something called the median that connected the midpoint of opposite sides. Well, we can connect the midpoint of the two bases together, but if we connect the midpoint of the two non-parallel sides together, we get something called the median. And the median of a trapezoid is a line, ray, or segment that intersects the midpoints of the non-parallel sides so that the segments that are cut by those sides, or the segments that are cut on those sides, are congruent. This should start to look very familiar related to setups that we've seen with other things before. Go ahead, pause the video, copy down the definition of median, and come back when you're ready for one more slide. Finally, the last type of unique quadrilateral that we have is something that we call a kite. And a kite is a quadrilateral with two sets of adjacent congruent sides. In this case, it's not opposite sides that are congruent. As you can see, the two sides that make up the top of this diagram are congruent, and therefore they are adjacent congruent sides. And the two sides that make up the bottom of the diagram are congruent, again, making up congruent adjacent sides. Now, something that must be true about a kite is that it cannot be a rhombus, which means that we can't have all sets of adjacent sides being congruent, otherwise every side would be congruent. Instead, we need them split into two distinct groups, where one set of sides is congruent, but not congruent to the other set of adjacent congruent sides. So go ahead, pause the video, copy down this definition as well as the diagram. Make sure you pause the video because it's about to end, because this is the last slide. But those are the two remaining types of quadrilaterals that we have, trapezoids and kites.